Here's a nice math problem on the web-based electrolysis experiments. Question number 16. I've abbreviated the table here, but you should have received these numbers by doing the experiment with nickel and copper. And the nickel migrates over onto the copper electrode. The mass that got transferred was 4.38 grams of nickel. And the question 16 is saying, is this realistic? All right, so you will recall that the current in the experiment was a 12 amp current. And it says here that 1 amp is equivalent to 6 times 10 to the 18th electrons per second. I'm writing this the way you should type it into your calculator. That's 6 times 10 to the 18th electrons per second. And how many is that? Calculator should tell you 7.2 times 10 to the 19th electrons are flowing every second. That's a current of 12 amps. The time of the experiment was 20 minutes. That's 1,200 seconds. So if it's this flow per second, and we had 1,200 seconds, we get a large number of electrons transferred. My calculator says 8.6 times 10 to the 22nd electrons flowed in 20 minutes. All right, so that's part one of the calculations. I'll do the second part in a different color. Now that we know how many electrons have flowed, we can try to get to how much mass does that correspond to. So now I'm using the hint. If we have that many electrons, how many moles is that? This is Avogadro's number. I'll write it the calculator way. It's going to be very important that you use scientific notation here, because when you divide, you need to divide by the whole value. All right, so this is a small number of moles. My calculator says 0.14 moles of electrons. I'll do one more significant digit. All right. Now you get to apply this concept that the reduction of nickel ion to nickel metal is a 2-electron process. Therefore, this many moles of electrons does not produce an equal number of moles of nickel, but instead half that number. 2 to 1 mole ratio between the electrons and the nickel that is produced. All right, so this gets me 0.072 moles of nickel, and times the molar mass of 59 grams per mole. My calculator says, final answer, 4.25 grams of nickel should be deposited. I'll say transferred. It dissolves from the nickel anode. It plates onto the copper cathode. And you can see that's very close to the number in the simulation. The simulation is actually more accurate because it's using more precise values for Avogadro's number and this approximation here. This is how the computer simulation actually did calculate the mass of nickel that is transferred in the experiment.